Let's study about virtual destructor. Okay, so we know constructors are used to allocate assign values to the private data members of a class. If you have a class and you are having some private variables, right, to assign values to those private members of a class, we use constructor, and whatever memory is allocated for that constructor, to delete it we use the destructor. Right. So how do we write the constructor? Class name itself is the constructor name, and destructor is also same, but we have to include a tilde symbol. This symbol and the class name you have to give in front of that. So whatever memory is allocated will be deleted. So what is this virtual destructor? Let's see an example here. Right. So in this example, through program we will try to understand it. I have a class base. There is a public, I have a constructor and a destructor, and I have a derived class which is derived from this base class. Here also I have a constructor and a destructor, right? So when I create an object, right, when I create an object for this derived class, see, derived star d equal to new derived, this is dynamically creating, right, dynamically creating an object, allocating memory to the object dynamically. That because we are using a new keyword here, right? So I have created a object d, a pointer object d to derived class. Okay, I am creating an object d to this derived class. Okay, object d is belong to derived class. Now you see, base class star b equal to d. Right. So what I am trying to do, I am trying to assign the this derived class object to the base class object. Okay. So what will happen? Let's talk about constructors and destructors in inheritance. We have already studied. I'll just quickly go back to that slide to discuss that. Right. See, constructors and destructors in inheritance. We said that you can have a class, parent class, it has a constructor. Then child class, it is derived from parent class, it also has a constructor. When you create an object for the child class, right, which constructor is executed first? Is it parent or child? Which one do you think is executed first? Will this execute or this execute? When you create an object for the child class, right, parent class constructor is executed, then only child class executes, right? So here the output will be first inside base class, then only inside subclass. Though I am creating an object for child class, but since it's derived from the parent class, all the parent class constructors will be executed, then the child class. Right. Same is the case for destructors. I think, yeah, here we have seen this example. If we have an inheritance like this, so first the parent class will execute, then this child, then subchild will execute. Whereas destructor will go in reverse order, right? First it will execute the grandchild class destructor, then its parent, and then its grandparent. In reverse order it does, right? Now come to this example. See, here what's happening? I am creating an object for derived class. So which constructor should execute? Constructing base. This will execute first. Then also I am creating an object. For the base class. That I am assigning to the this derived class object. I am assigning to the base class. Right. So here when you create, we already know. Again, if you ignore this one statement, let us cover one point first. Assume this is not there. When you create a derived class object, parent class base will execute, then the child class base will execute. Okay. And when you write delete b, right, so it means, why am I again here? Let it be delete d for our this example. Let it be delete d. See this simple. Derived star d equal to new derived. I am creating an object. Memory allocation I am doing it using the DMA technique. Right. So this constructing base will execute, then the constructing derived will execute. Okay. When I write delete d, Okay, which one is getting deleted here? Delete D means this memory which I am allocated dynamically will get deleted. That's it. Okay, so what about this destructor? What about this destructor? Will it execute? No, destructor is not getting executed, right? Even if it is executing, this derived class destructor is executed because I am deleting D. When you write delete D, this derived class destructor is executed, but this parent class is not happening, right? For that, what we have to do, we have to use a keyword virtual. Why like this? Let me go to the virtual functions now. Let us combine those concepts. The concept of constructor, destructor, inheritance plus virtual function. Let me go back to virtual functions. Right. Virtual functions, no? Right. Right. See here. In runtime overriding, we are using virtual class. Why are we putting virtual class here? This example, let's try to understand. I'm just revising those concepts of constructor, destructor, inheritance plus virtual functions. See, I have a function display in base class, display in child class also. Right. So, what is happening when I am with the previous example here? See, print in base class, print in child class. So, when I create an object obj and write object.print, when I write object.print, it is no, here there is a chance that it is confused whether this one or this one, whether this one or this one. So here child class will be executed. Child class will be executed, right? So that's why we are putting a keyword virtual. When you put that, you are over. Whenever you want to implement overriding, we write virtual functions. When you write the keyword virtual, then there is no problem. When you execute, see, base pointer you have created and you are calling an object for this display executes. Okay, so this way we are trying to avoid confusion. Compiler is confused. Why we are going for this virtual function? Compiler is confused. Which one? This print or this print? Same name. Constructor, okay, but what about function? Right? We are trying to override that here. So to avoid that, to implement runtime overriding, we are including the word virtual. For runtime overloading, you definitely have to use virtual. Now let's go to our concept. Virtual destructor. Right. See here. A virtual destructor is essential in C++ when dealing with inheritance and polymorphism. To ensure that the proper destructor is called for an object when it is deleted via a pointer to the base class. Okay, see this example. I am creating a pointer to the base class and that I am deleting. Delete B. It means only this base class. So output for this, if I execute this program, so it will be constructor constructing base. It will be constructing base and then constructing derived and destructing base will come. This will be the output. Destructing derived is not coming as the output. Why it is not coming? Because I am using delete keyword. I am using delete keyword only for base class object. Okay. So this comes into picture. Here we are combining about the constructor destructor concept plus the virtual function concept plus the dynamic memory allocation techniques. See, I am creating an object using DMA technique. When you do that, you definitely have to use new to create memory and delete to delete that memory. When I am writing delete B, when I am after creating a derived class object, assigning that to base class object, I am only deleting B. I am not deleting the child class. I am not deleting the child class destructor. Okay, why this is not being executed? Why this function is not executed? Because you have allocated memory dynamically, and we have studied yesterday in dynamic memory allocation that if you are allocating memory, you yourself have to delete it. As a programmer, you have to write the deletion logic. Otherwise, memory will not be deleted. That is one very important point. So here I am allocating memory using new. I am creating a pointer to the, I am creating an object to the derived class using new. Unless until I write delete D, unless until I write delete D, this will not be executed. This destructor class will not be executed of the derived class. Okay, since I wrote here, since I am creating an object using new, now see the scenario here. I am creating an object for the derived class using DMA technique. Perfectly okay. Now I am creating an object for base class. I am creating an object for base class and I am assigning the derived class object. I am assigning the derived class object and I wrote delete B here. So which object I am deleting? I am deleting the base class object, or I am deleting the memory allocation of the base class object. So this derived class object or this derived class destructor is not executed. Answer will be only 3 statements, not the 4. That's what it is mentioned here. Right. So we have to use virtual destructor concept to ensure that the proper destructor is called for an object when it is deleted via a pointer to the base class. See, I am creating a pointer to the base class and I am deleting it. Right? In this case, we definitely have to use virtual destructor. When you delete an object through a base class pointer and the base class has non-virtual destructor. See, this is a non-virtual destructor here. Okay, when you delete an object through base class pointer, I am deleting an object through base class pointer here. I am deleting that B. Okay, and the base class has non-virtual destructor. Only the base class destructor will be called, leaving the derived class destructor uncalled. Okay, that's why you definitely have to use virtual destructor. How to use that? How to see? Simple. Just write virtual. Just write virtual in front of the base class destructor. Same program, no change, just adding virtual. Now let's see this execution. What happens? Derived class object is created. That is D. Derived class object is created. But for that D, memory allocation is happening dynamically. Now I am creating a base class pointer. For a base class, I am creating an object B. That I am assigning equal to D. I am assigning that to D. D is assigned to this pointer B. Now when I write delete B, what is the content of B? It has come from D. Right? So when you write it virtual like this, automatically the derived class destructor is also executed. The derived class destructor is also executed. So let's see this discussion here. If you don't do that, when you delete an object through a base class pointer, and the base class has a non-virtual destructor, normal destructor it has, only the base class destructor will be called, leaving the derived class destructor uncalled. Okay, so when do we have to use this virtual destructor? You should declare a virtual destructor in any class that may be inherited from and which may be deleted via the base class pointer. Okay, so if you are creating an object dynamically, okay, and deleting that object through the base class pointer, then you definitely have to use the keyword virtual, or you have to create a virtual destructor which will delete both, which will call both the parent class and the child class. Can you guess the output? In which order the destructor will execute? In which order the destructor will execute? Can you tell me in which order the destructor will execute in this virtual destructor concept? I am deleting directly the parent class object. Delete B. Which one do you think will execute? Whether the destructing derived or destructing base? Normally what happens? You forget about the other things. Okay. Normally what happens? See, when you write constructors and destructors, constructor will be called first parent class, then the child class constructor will be called. Whereas coming for destructor, first child class, then parent class will work. Okay. But here what's happening? I am creating a virtual base class. Right? I am creating a virtual base class. So base will be derived, then the child will be derived. First the parent will be deleted, then the child will be deleted. Okay. Let's quickly summarize this. Virtual destructor, when do we have to use it? Okay. In any class, in any program, okay, if you are creating or allocating memory dynamically. First point, if you are using dynamic memory allocation technique to create an object. Create an object. We know that if you are dynamically allocating, we ourselves have to use the delete keyword, delete function. We have to use this. Unless until you use delete, we cannot delete the memory allocation. Okay, that is first point. So yes, we have dynamically allocated memory for the child class object, that is D. Later, for the parent class, I am creating a pointer variable. For the parent class, I am creating a pointer object. Okay, which is assigned a value D. This is DMA. This is created through DMA. This D. This I am assigning to this base class object. And I am deleting the B only, not this D. So to use this keyword implicitly, delete D, just put virtual in the base class. When you put virtual in the base class, then both the destructors will be executed. Okay, so again, this is just this concept exists. If you really ask where is this used, you need not create a virtual destructor. You don't create a dynamic memory allocation. Simple. But if you are creating that way, you definitely have to have a virtual destructor in the base class. Only then you can do. Otherwise, if I would written this program, see, base star B equal to D, delete B, and also I have written delete D. Then there is no need of this also. When you write delete B and delete D, it's very simple. It will delete both the destructors normally, right? But if I'm not writing this statement and I want that to be this function and this function both to be executed automatically, you have to make one as the virtual. In that case, this will work. This is about virtual destructor in C++. Next, dynamic constructor. Now, dynamic constructor. Okay. We know constructor is used to assign values to the private data members of a class. We know that is the use of a constructor, right? Again, this is combination of the constructor concept plus the DMA concept. Okay, constructors we know normally class name is the constructor name, right? In every class you can have a constructor which will be by default executed as soon as you create an object. As soon as you create an object, the default constructor will be executed of the class, right? And why we use constructor? We use constructor to assign values to the private data members. We know this. DMA. What is DMA? Dynamically allocating memory to variables. Okay, if you are using DMA techniques, new and delete. This is used for dynamically allocating memory. Okay, that is DMA. Now, what is this dynamic constructor? When allocation of memory is done dynamically using DMA in a constructor. So, let's see this example. See, class name is student. Class name is student. In this student class, this is default constructor. This is the default constructor. I can write whatever I want to write inside the default constructor. We use it for assigning values to the private data members, but you can give any function here. Okay, so in a default constructor, if I am using DMA techniques to allocate memory, right, for these variables, then this kind of a constructor is called dynamic constructor. Simple. In a constructor using some DMA techniques, memory allocation is done using DMA techniques inside a constructor. That kind of a constructor is called dynamic constructor. Let's see the understanding here, right? When allocation of memory is done dynamically using DMA, that is new. In a constructor, it is known as dynamic constructor, right? By this, we can dynamically initialize the objects. Okay, so when we create dynamic memory within the constructor of a class, it is called dynamic constructor. So here, see this example, I have a class student and you know DMA, this is again, I am repeating an important point. Using DMA, you definitely have to use a pointer only. Why? When you write like this, new of int, when you write like this, what does this statement do? It will, if I write like this, int star ptr equal to new int, what it is doing? It is creating a memory block of size 4 bytes and the address of this memory block is assigned to PTR variable. Okay, the address is assigned to PTR variable. So definitely I have to use a pointer variable only. See, I have a pointer variable in the class. For that I have to allocate memory. I am doing it using this dynamic memory allocation technique. P equal to new int of 3. Again, this is one new statement for you. Int P equal to new. Generally we can write like this, int of 3 and leave it. So what does it means? It is creating an dynamically it is creating array of 3 integers. We have studied that yesterday, right? See, allocating memory for an array using new. What we are doing here? See, int arr equal to new int of 5. Int star arr equal to new int of 5. I am creating 5 values or array of size 5. This statement is equal to a of 5. Writing like this, int a of 5. Right. So this example, if you see here, I am writing, instead of writing int a of 3 semicolon, I am assigning the values here only like this. This is possible if you are dynamically allocating memory to an array, and if you want to assign that inside the program itself, you can write a statement like this. P equal to new int of 3. This indicates the create 12 bytes of memory, 3 into 4 bytes, and then 1, 2, 3. It means P is an array which contains 3 values. Those are 1, 2, 3. Okay. So this way I am dynamically allocating memory to an array. I am creating an array. Memory allocation is happening dynamically to an array inside the constructor. See, again there is some printf statement inside it. So student star ptr equal to new student. What is this? This is creating object dynamically. Student star ptr equal to new student. I am creating an object dynamically. Now once you create an object for this, immediately the default constructor will execute. In that, dynamic memory allocation is happening. Okay, so simple points. In a constructor, if you are using DMA techniques, or if you are using new keyword to allocate memory to variables, or you are creating new variables, or maybe you are assigning values to the existing variables, then we say that kind of a constructor is called as dynamic constructor. Okay, this is about dynamic constructor. When we create dynamic memory within the constructor of a class, this is known as dynamic constructor. Okay, so we have seen virtual destructor and also dynamic constructor.